Okay, so we're going to start off by talking about solving linear systems of equations by graphing. So in order to build this standard up, we're going to need to go back probably to some problems that you've probably done in 8th grade. And so specifically in Algebra 1, which is going to be mostly the focus of this, because hopefully by Algebra 2 you should be comfortable with this, but we are going to cover this in Algebra 2 as well. Your goal is to write and solve a system of linear equations in context. So we're going to build up to the in context part, but we're going to talk about methods of solving systems of equations first. And then in Algebra 2, what's interesting is that it refers you back to the Algebra 1 lessons for our state. It says it's partially aligned, but you want to be able to solve a system of linear equations in context. So right here, we're going to start with graphing. So once I have an equation between a relationship between two variables in the form of an equation, the whole goal is to be able to graph the equation on a graph, a Cartesian plane, or an XY coordinate plane, and graph it. Okay? So let's go with the first example. So we've got y equals 1/4 x plus 1. Make sure that looks good. 1/4 x plus 1, so 1/4 x plus 1. And the next thing we've got is negative x minus 9, okay? So the first thing we want to do is we want to look at the slopes of these lines. So slope is not y equals mx plus b. That is not what slope is. The only part of y equals mx plus b that refers to slope is m. M stands for the slope of your line, okay? That's the rise over the run, which is we're so famous for hearing. So that's going to be important. So picking out the slope, and then the b term is your y-intercept. So m is slope. And then your b is your y-intercept. So we're going to put these in what's called slope-intercept form for these lessons. There's different ways that you can do that. But slope-intercept form shows you the slope. Y equals mx plus b shows you the slope and where it intersects the y-axis. Okay? So that's going to be a coordinate. So we'll talk about that. And then down here, if I don't see a slope, if I have a negative in front of an x or just an x by itself, then the slope is understood to be positive or negative 1. So what I'm going to do in its place is just replace it here. That's going to be negative 1 over 1. So negative x is the same thing as saying negative 1 over 1. So that tells me the slope. So now what we're going to do is graph these lines. And the goal is once you graph them, you're trying to find where they intersect. So I'm going to graph both in different colors, red and blue each time. So the first one I'm going to graph it red. Okay? So this first function, I want to know where it hits the y-axis. So it hits the y-axis at this y-intercept. So for hitting the y-axis, I'm going to have a coordinate, which is 0. So my x is going to be 0. And my y is going to be this b term. So that's going to be 1 in this case. So 0, 1. And then from there, I'm going to use my slope, which is my rise over my run. So this tells me to go up 1 and right 4. So the negative or positive tells you to go up, and then the bottom always tells you to go right. So from this point, I'm going to go up 1 and right 4. Up 1 and right 4. And from that same y-intercept and slope-intercept form, I can go down 1 and left 4. So that pattern continues. If I want to go down 1, I can go left 4. So just the same situation in the opposite direction. So hopefully that's making a bit of sense to you. And that is the graph. Okay, so that's the graph of the function. So now what we want to do is we want to find the y-intercept for the second graph, which I'm going to do in blue. And it's going to be the same as the first. It's going to, as long as I've solved for y, I don't have to search for the y-intercept very much. So down here, my y-intercept is -9. So I'm going to have 0, -9 is my y-intercept. So I'm going to erase all this stuff. Okay, so -9 is my y-intercept, so 0, -9. I'm going to go down 9. And then from that point, it's telling me to go down 1, right 1. So let me zoom in on that. A negative upstairs tells you to go down 1. So down however many number, or whatever that number is. So -1 tells you to go down 1. And then the bottom always tells you to go right, is what I tell my students. So down 1, right 1, which isn't really... It's not, I'm not being like precise with my language here. I'm just trying to get the point across, okay? So from that point, I'm going to go down 1, right 1, and the pattern continues. And then from that y-intercept, I can also go up 1, left 1. But once you start to graph some of these guys, you get the feel for where they're going to intersect, and you're starting to be able to graph these lines and understand what the slopes are and where the y-intercepts are, and now you can start to look for the intersection. And I recommend graph paper for this, right? If you're going to graph these on a regular sheet of old paper, it's going to be kind of hard to see exactly where they intersect. But with graph paper, you can kind of see almost exactly where they intersect. And if you take a look here, these guys intersect at, let's see, -1, -2, -3, -4, -5, -6, -7, -8, -1 is where they intersect at. So that intersection there is -8, -1. And so the solution to both of these lines, the solution is -8, -1. So if I plug those in, I'm going to get the same value on both sides, okay? So they share one point. These two lines share one point, and that one point that they share is -8, -1. That's what we're trying to say here. So this is example 2. So I've got y equals 2x minus 8 and 13x plus 2y equals 18. So what I want to start to do is solve these two equations for y. So the first one's already solved for y, so it's in slope-intercept form. So I can actually graph that guy. But before I graph both of these lines, personally I like to get them both in slope-intercept form first, okay? So it's very difficult to see where these lines, how these lines are graphed if they're not slope-intercept form. So this line, the second line, is in standard form. That means the x is first with its coefficient, the y is second with its coefficient, and then it's equal to some constant. So what I want to do is I want to solve for this y. So what I'm going to do is subtract this 13x to the other side. So I'm left with 2y equals -13x plus 18. And then what I can do is divide both sides by 2. So I get y equals -13 over 2x, and then 18 over 2 is 9. For your slope, your m value, your coefficient on x, that number in front of the variable there, the number in front of x, what you want it to do is you want it to actually be in fraction form in this case. Even if you're uncomfortable with fractions, converting it to a decimal is going to get hairy. What you want to do is you want to be able to see how far down or up you go and how far right or left you go, depending on your line. So if I go over here what I'm actually going to do is graph that point. For the first one, your point of intersection is -8. So in other words, this b term over here, this -8 is your y-intercept. So 0, -8 is where that function is going to hit the y-axis. So I'm actually going to have to move this plane. So 0, -8, and I'm going to graph that function in red. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So there he is. So he's down there, -8. And then for the next line, it's telling me that my y-intercept is +9. So this is going to be 0, 9 is my other intercept. So I'm going to do that in blue. So make sure you're giving yourself some sort of labeling. I like to do different colors to show that the lines are different, so you can do what you want there, but particularly for me, I like to do different colors so I can tell the difference between my lines. And so that's my y-intercept there. So it's up 9. And now I want to work with the red again. So I'm going to work with this red line up here. And I see that my slope is 2. And I don't have it as a fraction yet. So anytime I have a constant in front of that, a whole number that's not in fraction form in front of that variable, I want to put it in fraction form, so I'm going to put 2 over 1. So 2 divided by 1 is still 2, but it tells me where to go. So my rise is 2, means I'm going to go from my y-intercept, the red y-intercept, I'm going to go up 2 and then right 1 and continue that pattern. So I'm going to do that over here. So I'm going up 2 and right 1, up 2, right 1, all the way up. So that's what my line looks like. And then from -9, it's telling me to go down 13 and right 2. So we're actually going to do that in blue. So from 0, 9, I'm going to go down 13 and right 2. So from 9, I know that 0, 9 is 9 units from 0. So this is 9 units down. So I need to go 13 units down. So 10, 11, 12, 13, and then right 2. And so what that does is it tells me where these lines intersect. And so I can kind of continue that pattern. It's not perfect, but I can kind of see exactly where they intersect, which is 2, I think, -8. No, not 2, -8. It's been a while. 2, so 1, 2, -1, -2, -3, -4, yeah, 2, -4. So the solution to both of these graphs is 2, -4. It tells me where it hits. Both lines intersect, and that's exactly what I want. I want to know where both lines intersect, okay? So let's go on to example 3. Well, example 3, I've got 3x minus 2y equals 10, and x equals 2. So those are my two graphs. So anytime you have x equals number, it's a vertical or straight up and down line at that x value. So we're going to graph that guy first because it's going to be the easiest one to graph. And if you haven't seen it before, it's a great way to look at it. So all I'm going to do is find x equals 2 on the x-axis, so 1, 2. And then at 2 there, I'm just going to graph a straight vertical line, and this time I'm going to do it in my new favorite color, which is indigo. So straight up and down there. So that's what that line looks like, and that's it. We're done. So if you get x equals number, you go to that number on the x-axis, draw a vertical line all the way through. Just straight up and down, no slope. You're done. The other one, I want to solve for y. So I'm going to do that, and there's more than one way to do that. I'm actually going to get rid of the 3x. So down here, I've got 3x minus 2y equals 10. So I'm going to subtract 3x from both sides of the equation. So I get negative 2y is equal to negative 3x plus 10. And then I get y is equal to 3 over 2 minus 5. So 3 over 2x minus 5. So what this tells me, right, is now that it's in slope-intercept form, right, I divided every number by negative 2. So you missed that step. That's what I did from there to there. So maybe I should show that. So I've still got a negative coefficient on y here. And I take and divide negative 2 from each term. And I get y equals 3 over 2x minus 5. Okay? So 3 over 2x minus 5. Negative 3 divided by negative 3 is positive 3 over 2. 10 divided by negative 2 is negative 5. Negative 2 divided by negative 2 is positive 1, or just y. So I have a y-intercept here. I'm going to do this one in, I don't know, blue. Or green. Yeah, I'll do it in green. This negative 5 tells me that my y-intercept is 0, negative 5. So I can go over here. Oh no, it's broke. Okay, we're good. So 0, negative 5, and then what's my slope? Well, it's going to be up 3 and then right 2. So from that green point, up 3, 1, 2, 3, right 2. And then again, up 3, right 2, up 3, right 2. But you can stop whenever you're done. I'm just trying to show that those lines keep going on, and then I can go still from that point down 3, left 2. So remember, this is a straight line. So whenever I'm trying to draw this from that y-intercept, you go up however many, down however many, and then right however many, and then you can go in the opposite direction. So for me, I went up 3, right 2, up 3, right 2, and then to get that same motion in the other direction, I can go down 3, left 2. Because you're essentially saying you're going negative 3 and then negative 2. So negative 3 divided by negative 2 is still positive 3 over 2. So it's still a positive slope. So that might be a little confusing for you. I'm not trying to do that. I'm just trying to show you why you can go in both directions. And if you can see this green line, it is straight. It is a straight line. So what this tells me is that the intersection is 2, negative 2. So the solution to these graphs is 2, negative 2. And you might be saying, oh, well, that's great. I need a really hard one. I don't understand it unless I get a really hard one. Well, here you go. Example 4. Negative 12x equals 30y plus 60. And then 2x plus 5y equals 20. So we want to solve these out. So what we're going to do is we're going to solve for y in the first equation. So I'm going to do that by subtracting 6 from both sides of the equation. So I'm going to do that over here. So I'll do this in red. So first I'm going to flip-flop the two sides. So anytime you have an equal sign, you can write whatever's on the right-hand side on the left-hand side. and set it equal to the left-hand side and the right-hand side. So I just swap the two sides of the equal sign. That's perfectly fine. Now I'm going to subtract 60. And so I get 30y equals negative 12x minus 60. And I can divide 30 on both sides. So I get y equals negative 12 divided by 30. Well, I can divide 12 by 6, which is negative 2. And then I can divide 30 by 6, which is 5. So negative 2 over 5x. And then negative 60 divided by 30 is negative 2.
Miss Becky, I found my keys. Thank you.
Okay. And then over here, I've got 2x plus 5y equals 20. So what I can do is subtract 2x from both sides, so I get 5y equals negative 2x plus 20, and then I can divide every number by 5. So I get y equals negative 2 over 5x plus 4? Yeah. And so you might be a little confused because these two graphs look the same, look very similar. The only thing that they differ in is their slopes. So over there, this is negative 2 over 5. The only thing they differ in is their y-intercepts. Their slopes are the same is what I meant to say. So I apologize for that. I did not mean to say that. And over here, negative 2 over 5 is their slope. Okay, so what we want to do is graph both of these functions. So I'm going to graph the red one first. And so the red one is negative 2. That's your y-intercept. And so from that point, you're going to go down 2 and then right 5. So that slope, again, tells you where to go. So that the top tells you to go up or down. So if it's negative, it tells you to go down 2. So negative 2 units down, and then right 5 units. So we're going to do that. Down 2, right 5. Down 2, right 5. Up 2, left 5. And that's it. That's all you have to do. And it's kind of dicey there, but that is, yeah, that is the line. He's not pretty, but he's my line. And then the next one is I'm going to go up 4 with that green line. Sure, 1, 2, 3, 4. And so that's my y-intercept. And from there, I'm still going to go the same slope. So I'm going to go down 2 and then right 5. So down 2, right 5. No, that's right. Yeah, that's correct. Right 2, down 2, right 5. And then up 2, left 5. So there we go. And those are my two lines. And so what's going on here is I've got two different lines. So like this. Oh, for you it's, yeah, like that. So what I've got here is two different lines. But if you take a look, if they have the same slope, what that means is that they're never going to intersect, okay? So this is about as hard as it gets as graphing lines. So this is a really, really good practice session. So what I really recommend is if you struggle with any of these, either get yourself a worksheet, try it out on your own, or go back, pause the video, see if you can work these problems on your own, and then look at the solution. And if you get it right, just make sure that you're working the problem and you kind of forget, don't forget like the solution path, but just kind of forget the numbers. And so maybe try a few of these out, but hopefully this helps you out on how to work the problem. But that's all I've got. Take it easy.